Here we are at example 7 from our 0.1 number 2 set of notes. We're asked to evaluate pretty much each expression where we know that A is 8, B is 4, and C is 16. So we're going to go ahead and just substitute these items in and pretty much see what we end up with. With our A, we know that that is 8, that's being squared, times our B, we know is 4, times our C, we know is 16. Minus our B is 4, and that is being squared. The first thing what we're going to go ahead and do are the parentheses. Well, they all have parentheses, but nothing can really be done within them. And then we're going to move on then to the exponents. So we notice that we have an exponent here and here. So looking at the basis for those exponents, 8 being squared gives us 64. So again, for that operation, we end up with 64 times 4 times 16 minus 4 squared gives us 16. Now there's actually a variety of different approaches we can go from here. Personally, I think that going like 4 times 16 gives us 64 times this original 64. Might be an easier route, but if you are good with like kilobits and you kind of know the laws of 2 and exponents, you can kind of get around doing 64 times 4 minus 16. And for this, we'll actually go ahead and multiply out. So if we have 64 times 64, that's 16, 1, 24, 25, 0, we have 24, 36, 38, add that together, 6, 9, 0, 4, so 4,096, kind of a big number. Then we also have to subtract 16 from that, so it looks like we end up then with a grand total of 4,080. That would be our most simplified version when we go ahead and evaluate by substitution. Again, though, that is example 7 from our 0.1 number 2 set of notes.